our planet Earth, held exactly near a sun to keep us warm, always spinning, warming, cooling, and shaping, over millions of years, over thousands of years, sometimes over decades, changing in predictable cycles. The physics of planet systems is now more understandable to scientists. That's why we decided to produce this scientific presentation in analysis, to summarize measures and carefully projected simulations for a better understanding of the current and future probabilities of forces that may be exerting change to our planet. From a careful study of measured dynamics in celestial physics and relating them to the many changes, or in scientific terms, anomalies, that are currently underway on our planet. Ones including strange new trajectories of our North Pole and South, with the North speeding up and moving faster than the South. Similar changes in other magnetic areas, including a South Atlantic magnetic anomaly, splitting with each moving in converging trajectories with the changing magnetic poles, in line to possibly meet each of the new poles, all measured as continuing on course. A measured new offset or wobble on our planet that may be causing unusual fluctuations in global seasonal temperatures, such as unusual cold and snow to mid-tropic regions, unusual warm in a cycle to some regions in the northern hemisphere. Our Earth is also spinning faster than normal and speeding up, while our magnetic axis has changed due to both pole movements. Analyzing measurements since 1590 with older data available thanks to bearings provided by many logs of ship captains traveling the world at the time. More currently, mission satellites to the measuring, along with many land sites and techniques utilized across the globe. All on the evidence something new is happening to our planet, magnetically, and perhaps in other ways. And we're on a journey to measure it, simulate it, forecast it, and prepare with it to the best of our ability, on best available quality scientific data sources, toward expanding our understanding to somehow make sense of our changing Earth, and whatever we can reasonably expect to result from those changes. Our solar system. If we are to understand our Earth and any changes that sit in its potential, then we need to look first to the other planets to see what features they display compared to Earth. Seems a most reasonable place to start. Since our planet's magnetic axis, spins, and angles are in new types of movement, we considered mostly these and related features on other planets. And what we learned was quite remarkable. It seems all planets have some unusual feature to their magnetic makeup from a rather small sampling of planets. First up is the reverse spinner, Venus, a small hot planet. It rotates very slowly in an opposite direction to Earth. Otherwise, its axis is upright with a central magnetic placement. For this planet, all seems relatively normal. Moving to Uranus and Neptune, however, we see some other peculiarities, features in magnetic axis and rotation that are different than most planets. First, with Neptune, the planet is in the far cold region of our solar system and rotates in the same direction as Earth and almost at the same angle to the Sun, about 28.3 degrees, with Earth at 23.4 degrees. An unusual feature of Neptune is that it, as observed, as with NASA Voyager 2, its magnetic axis is off-center from the planet by 46 degrees, much like what Earth is currently measured from 1903 to 2021. An off-center magnetic axis from north and south pole magnetic movement. From the space view of Africa, Earth is almost similarly disaligned as Neptune, and continuing to change in the Earth case. Uranus rotates on its side at 97.8 degrees, making it a little upside down. If that's not strange enough, it also rotates in an offset against its poles. The sun rises in the near south and sets in the near north. The other notable feature of Uranus, as with Neptune, the magnetic axis is off-center from the planet, a more exaggerated 60 degrees removed from the rotation central axis. Another planet demonstrating not only what is possible in a planet system at some stage of its cycle, but also a rare view of similar magnetic features, as now demonstrating with some peculiarity here on Earth. Back to Earth. Well, almost to Earth. Our system works similarly to other planets in terms of rotation, movements, and cycles. Some planets are in different cycles than Earth, but on scientific evidence, ones that may be a possibility in Earth's near future, and that require careful and close measure and analysis to improve our understanding. As we look to Earth's history, we have also seen much change. Fortunately for us, we're at a habitable stage in Earth's design, and it works until it doesn't. When features are not acting normally, we must simply use good judgment in the balance of scientific facts and probabilities, and anticipate and prepare best response to that change. So let's do just that. Explore climate impacts, including the newly demonstrating features of our magnetic Earth. Looking closer into our shifting poles, the South Atlantic anomalies, and the off-centering of Earth's magnetic axis, similar to Neptune and Uranus. And assess other potential risks, whether in medium-high probability of occurrence or not. All based on careful scientific review from our observable universe. Being careful not to provide any finite or definitive conclusions, but merely exploring the possibilities on evidence. It's entirely up to you, each viewer, to either support, discard, or expand the expression of changes that may be occurring with our planet. Climate and weather impacts. A planet warming. It has done so many times before, but also forcing a cool in other areas. Cooling oceans in the equator from glacier melt, pushing a warm into other oceans, creating off-season weather in many areas of our planet. Very unusual snowstorms in Saudi Arabia, Texas, and in other areas. A record-breaking season in mid-Atlantic tropic storms, and more. Not our normal calm of seas, winds, and lands. There's more than usual going on, and we're peeling the onion to find the answer, layer after scientific layer. Our magnetic Earth. Our planet climate system appears to be growing in intensity, but also confining to traditional storm corridors, fortunately. Our system of Earth's magnetics is also changing, but more quickly than in recent centuries and decades. In a previous unmeasured trajectory and speed. The prospect of the magnetic North Pole in movement is not new to the Earth, based on tracking from 1590 to today. It moves all the time. However, since 1590, the movement has been confined to northern Canada. That was until about 1995, when the magnetic North Pole began accelerating in a trajectory toward Russia. Normally, both the North and South Poles move, with the stronger South Pole less movable since recordings, and the poles sit in line that separate major regions of the magnetic polarity, sort of a positive and negative in the Earth. As we look back to the Earth's magnetic, in 1733, there was a clear divide between positive and negative in magnetic declination of the North Pole. It sits well in two divided sections of red and blue. Looking a little ahead in 1833, this represents a large magnetic intrusion moving toward the North Pole from Asia. Advancing to 1967, the Asia magnetic intrusion is hastening to the North Pole. In 2019, the approaching magnetic intrusion split the magnetic North Pole and has since been advancing much more rapidly toward Asia, in a trajectory not previously measured, in the same direction as the mini movement between 1590 and 1792, but farther and faster than ever recorded. The Earth is speeding up in rotation speed, although only by 1.4 milliseconds per year in 2020. It's been slowing down most years until 2019. The official projection for 2021, although adjusted often, is a record-breaking 58.27 milliseconds increase in the Earth's revolution speed. We're spinning a little faster than normal. If this was happening alone, then perhaps not a significant occurrence, but when you consider all the measures acting out of reasonable norms, it's time to stand up and take closer notice and look at all the change that can be assessed scientifically. As now, the magnetic axis of the Earth is starting to resemble features of Uranus and Neptune, which, as you know, spin in strange orientations to their poles. These cold planets may possibly represent some point in the Earth's polar cycle that relates either its past or its future. Only in time and measure will tell the whole story. But in the meantime, we measure and forecast probabilities using all known and in old and modern physics. The Dzhanibekov Effect. In 1985, at the Russian orbital space station Salyut 7, cosmonaut Vladimir Dzhanibekov was unpacking supplies delivered from Earth. While removing a T-handle, it commences a cycle of rotation that seemed to defy all known physics about rotating bodies in space. It turns 180 degrees after a short pause at the equatorial plane, and then repeats the pattern in reverse, over and over. Although totally by accident, the Dzhanibekov effect may be one of the greatest discoveries in our geological history, particularly as it seems to explain the method by which celestial bodies such as Uranus, Neptune, and even possibly Earth may be altered in spin plane relative to an off-centered magnetic axis condition. Like the new forces currently exerting changes to the Earth's magnetic spin and features. As we analyze the Dzhanibekov effect more closely, the geometric trajectory is regular in pattern in both directions, forming a reliable system, one that can be measured quite precisely. But the real question is, will larger celestial bodies, such as planets, react in similar trajectories to the T-handle? Planets, such as our precious Earth. Physics is always considered a fundamental science, in that when a new theory is proven experimentally, it transcends all known chemistry, biology, and so on. That's what makes physics discoveries so important, like the Dzhanibekov effect. If the Earth's changing poles are following the geometric trajectory of the Dzhanibekov effect, it will reveal rather quickly as we continue to track magnetic North Pole movement. For now, the magnetic North Pole is, in fact, on track for such a Dzhanibekov loop, and unless its direction and speed changes significantly, it is prudent to consider the probability of its occurrence and possible further disruptive effects that such conditions may have on our life here on Earth, and on projection of current trajectories and conditions when any major disruptive or destabilizing events may occur. If such events do display, well, so that we're best prepared by all possible ways and means. The Earth's geological clues. Committed groups of international scientists working in many different fields of study have uncovered some clues that may help us identify patterns in our planet's history. Evidence that supports the occurrence of a similar event approximately 40,000 to 42,000 years ago. A great flood that encompassed most of the planet in geological record, specifically derived from C14 carbon dating results from fossil woods, Cripple Creek, Colorado, USA, and supported by samples from Crinum, Queensland, Australia, and from Redding, California, USA. Another interesting clue stems from an ancient karuri tree found in New Zealand in 2019. A group of international scientists were able to confirm that the ancient karuri was alive 41,000 to 41,500 years ago, meaning the rare tree occupied the land during the geological record identified at the time of the Great Planetary Flood. What becomes interesting is that over the tree's 1,500-year lifespan, scientists were able to accurately identify severe environmental impacts during that period, including large shifts in major wind belts and tropical storms, amongst other things. The Earth has also been revealing to support evidence of magnetic change, or in scientific terms, an excursion that is also timed to have occurred approximately 41,400 years ago, as evidenced in a 1960s discovery in the Lachamp's lava flow in Clermont-Ferrand, France. Accordingly, a shift in geomagnetics has previously occurred on our planet, and on finding, it has been termed the Laschamp event, or Laschamp magnetic excursion. And the resultant environmental impacts, at least as indicated by New Zealand's ancient karuri tree, evidence as potentially very severe during such events. If we are in fact in a repeating cycle of the Laschamp event, it is considered prudent to monitor and evaluate current changes to our planet in light of an ancient planetary occurrences and any new findings that help us discern the truth. What else can we possibly expect to occur during a major magnetic excursion? Planet Earth in a Dzhanibekov effect. If the Earth's magnetic North Pole continues on a trajectory in speed and vector as adjusted to a slower celestial timescale that correlates with the predictable Dzhanibekov loop, then, considering its recent measured speed of trajectory and possible environmental impacts on our planet, becomes of concern. A careful and closer view of measure and projection is required. This chapter deals with modeling the scenario of the Earth's magnetic North Pole as continuing to move along its current trajectory, and continuing in line with the Dzhanibekov effect, and to further measure and forecast possible resultant pressures and forces that could exert on our Earth's weather and major geological settings due to a possible magnetic excursion. So on that, let's start with the timing. On evaluation of simulated projections, given the current speed and trajectory of the magnetic North Pole, an entire Dzhanibekov loop essentially tilting the planet as led by an aggressively moving pole is possible to occur completely within approximately 30 years, with a base year of 2020. The simulated scenario mapping the North Pole anomaly on the same schedule could reach the Tropic of Cancer by year 7 to 9. Further pause in a loop at the equator in approximately 12 to 18 years and reestablish near the Mercator South Pole in approximately 27 to 33 years, again from the baseline of 2020. Measures over the next 2 to 3 years will assist greatly to determine the probability of a Dzhanibekov effect either occurring or not on our planet, to a higher degree of confidence. Also on simulation, a forecast is modeled in the scenario of the surface forces that may be exerted at various points during an operating Dzhanibekov effect on our planet. As the Earth's crust is oblique, meaning a little fatter at the equator than the distance from the Mercator North Pole and South Pole, the Earth is not a perfect circle. The oblique means a portion of the Earth's crust at the equator falls outside that perfect circle, sort of like a little fat belly around the Earth, a bulge that aligns rather perfectly with our daily rotation or spin, creating a centripetal force keeping us in place like a rock on a string. Only the string is the Earth's magnetic forces that keeps everything in its proper place. As the Earth possibly rotates in a complete Dzhanibekov effect, then there may be newly competing forces exerting against the planet's current spin axis in a transitional disalignment until the entire effect completes. On best analysis of simulation, from currently available data in relation to measures, the range of approximately 500 kilometers north and south of the Tropic of Cancer becomes a critical point relative to disaligning Earth's magnetics and spin cycles. It's approximately when the moving magnetic North Pole reaches the Tropic of Cancer that simulation analysis suggests a possible destabilization point for Earth's crust. It is at this point that an estimated Earth's normal spin direction may be disaligned by the movement of both magnetic poles and may further exert disruptive angular forces on major sections of the Earth's exposed oblique. Those sections of crust that bulge mostly between the tropics of Cancer and Capricorn. It is if and possibly when the magnetic North Pole arrives at the vicinity of the Tropic of Cancer in magnetic movement of a Dzhanibekov effect that the Earth's crust may destabilize into aggressive continental shift, continue to build upon effects, and remain in such aggressive shift condition until the magnetic North Pole reaches the vicinity of the Tropic of Capricorn. Furthermore, the period of a possible Dzhanibekov loop as simulated to potentially occur near the equator may cause the most severe and mobile conditions of continental shift through the entire effect cycle, estimated on simulation to possibly occur within 12 to 18 years from the base year of 2020. It is during this simulated period in the middle of the complete effect that the Earth's normal spin axis will be maximized out of phase, approximately 90 degrees relative to the newly formed and angular movement of the Earth's moving magnetic axis. Since 2019, the Earth features are showing us many signs, ones we can now measure very carefully and analyze with computational efficiencies to enable very complicated models of simulation and forecast. We have the display of other exoplanets and their changed features that help us study the problem and identify its possible triggers, timing, and effects. We now have an ability to measure, study, and understand our Earth's geological history like never before, with all its many signs of change. Missioning modern satellites and ground studies to cause, a scientific means that was simply not available to our ancestors, particularly during any of Earth's turbulent times. If any such an event as the described magnetic excursion is to change our planet's orientation for a period, whether for 30 years or for 50 years in duration, we best be prepared for any possibility. One thing may be for sure: whatever is happening to our planet, by all measure, means, and account, may be already well underway in a cycle set to happen, and continue simply undeterred by any means of human intervention.